In this video, we're going to look at sketching the reciprocal of a function, but in particular paying attention to a minor detail that is very easy to miss, but at the same time critical that it's in fact not missed. So let's have a look at the question to begin with. Sketch the graph of y equals 1 on f of x, given f of x is equal to 1 on x. Now, f of x equals 1 on x, that's your standard hyperbola. I've graphed it here already, so I might just write the equation here, just the function there, sorry, just to sort of make it clear that's what it is. And we want the reciprocal of this graph, or sketch the reciprocal of this graph. Now, we do know that there's a vertical asymptote, with all the y-axis is the vertical asymptote, so that's x equals 0. And there's also a horizontal asymptote, which is the x-axis, y equals 0, the equation of that. So the horizontal asymptote's not really the issue here. It's actually the vertical asymptote. What happens when you take the reciprocal of the asymptote, the vertical asymptote? So in other words, what happens here? Now, before we go any further, it's quite easy to see that if we start off with 1 on x, the function 1 on x, and we take its reciprocal, you end up with x over 1, which is simply x. So on the surface, it just looks like the reciprocal of the hyperbola is just the line y equals x. So it's just a line with gradient 1 passing through the origin. And if you sort of sketch this or graph it using any sort of graphing software, you would get y equals x. In fact, what looks like y equals x. Now, the next question I want to pose to you is, what is the domain of the original function? So this is the domain of 1 on x. Okay, so I might just write it here, in fact. So the domain of function x, which is 1 on x, okay, it's all real x, isn't it? Except though, well, obviously x cannot equal 0. I mean, you can't have 0 in the denominator. So it's basically all real x. However, x cannot equal 0. So if you were to use interval notation, it would look like this. So negative infinity, 0. There's the open bracket there, okay, and a union, and 0, and then to positive infinity. So that's sort of the two ways you can write that. So the point, or the domain x equals 0 is in fact excluded. Now that means then that the reciprocal cannot include x equals 0 in its domain as well. So the domain of the reciprocal, in this example at least, is also negative infinity to 0, union 0 to infinity. So in other words, all real x, but x cannot equal 0. So that means then that when we're drawing or sketching the reciprocal, we cannot include this point. So how do we show this on the same set of axes? Okay, we know that it's going to be the line y equals x. So I might just grab a ruler to make it a bit easier. All right, and okay, it's not the scale. So you actually have to miss the origin. But in its place, I'm going to put an open circle. Okay, and this would be the graph of y equals 1 on f of x. Okay, another way to look at it is like this, that y is equal to 1 on f of x, which is in fact equal to 1 over 1 on x. And leaving it in that form, we can see clearly here that x still cannot equal 0. Okay, because 1 on 0 is undefined. So at this point, we can say, well, we cannot include x equals 0 in the reciprocal. Even though if we start off with x, say y equals x, okay, so I might just write it up here. So if we start off with function x equals x, and we took the reciprocal of that, then you'd have 1 on x. Well, then x can equal 0. But because we're starting off with the function 1 on x, and we're taking its reciprocal, which kind of takes it back to x, but with just one sort of point of difference, x cannot equal 0. And even in the reciprocal, which is just x itself, so this is in fact y equals x, we still have to exclude this point because this point was not originally included in the domain of the original function, which was 1 on x. Okay, so hopefully that will assist your understanding of graphing reciprocals, and in particular, what happens when there's a vertical asymptote. Thanks for watching.